Hello, friends. Welcome to the Science Show. And today is January 3rd. And I would like to basically pick your brain in our Science Show live stream about the dark matter. And as you know, the dark matter is very elusive, which we can't see, we can't feel it. It passes through all the time from through our body, through our planet, sort of omnipresent material, and that is why it is very elusive. We cannot even see it, and therefore some scientists have said that we can probably find out the effect of dark matter, probably do the research. We place atomic clock near the sun. So that is the hypothesis that the scientists have said. It's a very good idea. So let us understand what will happen if we place an atomic clock very close to the sun and how this whole process is going to work. First of all, let us understand what dark matter is. Well, dark matter, believe it or not, is the majority of the substance that exists in space. And as per our understanding, dark matter comprises of all matter. 80% of the matter, or probably 80% of what we material that we have on our space consists of dark matter. The matter which we cannot study, we cannot see, and we cannot feel. We cannot even detect it in our sensors. There is no way we can interact with the dark matter. So can you imagine, friends, how peculiar this property of dark matter is? And we are made of only 20% of the stuff. Rest 80% is something which we cannot see, we cannot feel, very elusive. We cannot even measure the properties. We don't even know what kind of material dark matter is it particle, is it wave, is it electrons, is it fermions? So absolutely no clue about dark matter, yet it fills up our space, and it is the majority of the material that is available in the universe. So therefore it is very mind-boggling problem for scientists, because if dark matter consists of all the material which we cannot see, what that material is, that means the reality of the universe is something which is completely hidden from us, and that is what is baffling the scientists for very long time. And the theory that the new group of scientists that are proposing is putting atomic clock near the sun. So I will come to that in a bit, but the theory is that if there is dark matter everywhere, and dark matter is responsible for creating galaxies, creating stars, bringing the everything together, create gravity, and because of the gravity we exist, because our body takes shape, our planet takes shape. Therefore dark matter must be playing a major role in the formation of the universe itself. And if there is dark matter in the galaxy, there must be dark matter in our own solar system. We cannot imagine that, well, the dark matter is there in the galaxies, but in our solar system there is nothing like that. That is wrong. So the theory is that there must be a lot of dark matter, because we have these large planets like Earth, Jupiter, Sun, central star, which is very huge. So in order to form these bodies, there must be a lot of dark material available inside the solar system also. So instead of trying to study the dark matter out there in the galaxy, we can start by studying the dark matter which may be available in our own solar system. So that is the theory behind this new technique which has been proposed, and it's a very good technique. In fact, I will tell you that this is a very logical step, and if this fails, then we can actually move on to some other technique. But I think this looks very logical. This is putting an atomic clock near the sun. And as you know that the sun has a lot of gravity. 99.8% of the mass, visible mass, is present in the sun. And if the theory is about dark matter is right, that means whatever material that we see in our solar system, 99.8% is in sun. That means at least 5 times more dark matter must be available in the sun itself. So sun visible part is one thing, but the invisible and visible part must be exerting huge gravity. So if you send an atomic clock near the sun, it will impact the atomic clock gravitationally, and that is the whole idea. And as you know, friends, that atomic clock is very, very precise, very accurate, but atomic clocks are also affected by gravity and the theory of relativity, which was framed by the great Einstein. So if you send the atomic clock near a high gravitational concentrated area, then the theory is that because of the high gravity, there will be a time dilation. The time has to slow down because the gravity is impacting the atomic clock. Yet atomic clock is very accurate, absolutely accurate. There is no discrepancy or there is no time losses. So the clock, the gravity clock, will not feel anything. But when we observe the clock from Earth, we will observe the time is slowing down. And since it is getting relativistic time, it will start slowing down because the gravity of the sun will start impacting the atomic clock, which is there near the sun. And then we can actually have this atomic clock send a signal about the time, of probably ping another clock which is not close to the sun, probably near the Earth or even in the open space where there is no other body around the around that planet. So we can actually have the atomic clock close to the sun send a ping to the clock which is not in the high gravity area, and that will give us some implications about how dark matter or how much dark matter is take effect. So indirectly we are this method will help us analyze the effects of dark matter, and sun must be having a lot of dark matter, and that will also help us create a model around the dark matter in the sense that if we observe something visually, we can also run these new equations and tell how much gravity this body must be having, because the theory is that at least 5.5 times more mass must be there in that visible body. Same is true for Earth. If the mass of the Earth is x, that means the real gravity or gravitational mass must be 5x on Earth. So this method will help us create new theories, new formulas, new equations which we can feed in our computers and run different simulations. So this will also be very helpful when we actually travel out in the interstellar space, and when we are getting into unknown, we will also get chance to analyze various celestial objects or even black hole. When we observe something high gravity, then we can also find out how much gravitational pull the black hole, which is not visible, must be exerting because of the dark matter which exists inside the black hole. That will also help us prove whether there is dark matter inside the black hole, because black hole is not supposed to have exert the gravity. It exerts the gravity and we do not see any light coming out. So that will also solve some of our problem regarding the black hole. So I think this is a good idea, and as and when the results are out, I will bring them in our science show, and I meet you every day at 3 o'clock live and talk about these intriguing discoveries and inventions which are happening in the area of science. So as always, thanks for watching, and I will catch you again at 3. Meanwhile, I look forward to receiving your messages, especially on this subject. What do you think? So have a nice day, keep rocking, and I will catch you tomorrow again. Bye bye for today.